Welcome back to the deep dive. Today we're tackling a massive hurdle in modern professional AV.
A really big one.
Yeah, how do you get a perfect uncompressed 4K video signal across a huge space, like a massive room or even an entire building, without any quality loss?
Right.
So our mission today is to unpack the DVIGear DVI-2575-AOC Hyperlight Series cables and see how they're, changing the game for these long-distance installs.
And the distance is the immediate headline. I mean, we're talking about maintaining full HDMI 2.0 integrity.
Okay.
That's 18 gigabits per second of bandwidth up to 100 meters.
100 meters. So let's connect that to what installers actually face. That's, 328 feet. That kind of run used to mean complex, bulky signal extenders.
Oh, absolutely. Repeaters every 15, maybe 20 meters. It was a mess.
So what does this do for that kind of setup?
It just means massive simplification and reliability. You get rid of all those intermediate points of failure.
And it's not just about the distance, it's about quality, right?
It's flawless distance. These cables support the maximum resolution, 3840 by 2160 at 60 hertz.
And crucially, with 24 bits per pixel RGB color.
Which is what pros call 4.4.4 color.
So for you, the listener, why is hitting that 4.4.4 color space so critical in a professional setting?
It guarantees zero compression. I mean, if you're dealing with high-end video walls, broadcast, or post-production work, you need every single bit of color data.
No shortcuts.
None. 4.4.4 ensures that color fidelity is perfect across that entire 100-meter run.
Okay, so to get that kind of performance, you need some serious hardware inside. What's actually driving the optical signal here?
It all comes down to light, specifically 4 discrete optical channels running over what's called polyfluorinated optical fiber, or POF.
Which is, I assume, different from standard glass fiber.
Yeah, it's a highly durable, really lightweight alternative, much less fragile. But the active elements, that's what truly matters.
The transceiver modules, how do they convert the signal from electrical to light and back again so fast?
They use these incredibly efficient, tiny lasers. They're called VCSEL transmitters.
Okay.
You don't need to know the acronym, just know these things are optimized for pure speed over this type of fiber. That robustness is what keeps that 18 Gbps signal pristine.
So if the high-speed video is running on pure light, why is it still a hybrid cable? I see it still has 6 copper wires inside.
Right. So that copper is still critical.
For what?
It handles the low-speed signals, things like the HDCP handshake for content protection, and most importantly, power.
I see. So by splitting the jobs, you get the best of both worlds.
Exactly. And because the video runs over fiber, the cable has near total immunity to environmental noise.
That's the low RF EMI profile. That resistance to interference is a huge win for, say, a server room or a hospital where you can't have signals leaking.
It's a genuine security benefit, for sure. And because those active components are so low power, we're talking less than 1/4 of a watt.
Well, let me guess, it powers itself from the source.
That's it. It pulls all the power it needs directly from the HDMI source. No external power.
Which is one less thing to fail in a big install rack.
One less thing to troubleshoot.
Speaking of installs, let's talk practicals. It's plenum rated, which is a must for air handling spaces. But how friendly is it to actually pull through a wall?
This is where installers really love it. The cable is extremely flexible. It has a minimum bend radius of just 2 millimeters.
2 millimeters? That's tiny.
Yeah, it can handle tight corners that would just snap or completely flatten a traditional copper cable.
And they made the connectors removable to make that pull even easier, right?
Exactly. You pop off the HDMI docking connectors, and the cross-section shrinks down to just about 12 by 10 millimeters.
Wow.
It turns a really frustrating job of pulling through a crowded conduit into something much, much smoother. It's just efficient.
So let's sum this up. We've got a cable that hits the professional holy grail, 18 Gbps bandwidth, 4K 60p fidelity, over an incredible 100 meters.
And it's immune to noise, its power draw is minimal, and it's designed to be easy to install.
So this all brings up a really interesting question for the future and for you to think about.
If these advanced noise-immune hybrid cables can do all this, reduce power needs, meet top specs like 4K 60p over 100 meters using durable optical fiber, what does this reliance on light mean for the future of traditional bulky copper cabling in commercial installations?
It really forces you to ask, how much longer will copper be king?